Okay, everyone. Okay, so everyone, I think we're going to get started. So welcome all of you to this laser talk, and thanks for joining us for a great night of Art Science Chat. My name is Elizabeth Stevens and I'm from the University of Queensland, and together with my colleague Grayson Cook from Southern Cross University, I'm really delighted to be the co-host of this evening's event and to be co-convening the first laser series based here in Australia. We're meeting on many countries today, and so I'm going to invite you to start this evening by inviting you to share and acknowledge the country that you're on today, that you're joining us on in the chat. For myself, I'm on the unceded land of the Yugara and Turrbal people, and so I'd like to start by paying my respects to their elders, past and present, and to welcome any Aboriginal or Torres Strait Islander colleagues who are joining us here today. I'm fortunate to be in Meanjin, Brisbane today, land that has always been a space of culture and learning, and I'm grateful to be able to continue that with all of you this evening. Laser Talks are a program of international gatherings that are held under the auspices of the Leonardo Journal, which bring together artists, scientists, humanists and technologists together for presentations, performances and conversations with the wider public. Grayson and I are really thrilled to be the co-host of the first series of Laser Talks to be held here in Australia. And in fact, this is the third of our events that we've staged together. So we have an exciting lineup and a packed house for you here today. So to introduce tonight's topic and to introduce our fabulous speakers for this evening, let me pass you over to Grayson now. So over to you, Grayson.
Cool. Thanks very much, Elizabeth. And hi, everybody. Welcome. I'm very excited to be co-hosting this event for you. I think we've got some fantastic speakers for you. I'm really pleased to be coming to you from Ballina in northern New South Wales. This is beautiful Nyangbil country, part of the Bundjalung Nation, and I pay my respects to elders past, present, and emerging. So this is the first session for this year, and as we were casting around for topics, it struck me that there were a couple of my colleagues and collaborators and people I've been worked with, and I've been sitting on panels over the last couple of years that I really wanted to be able to bring together and convene a session around. And so Alinta Krauth and Dave Newell are our speakers for the evening. Alinta's work, Alinta is an incredible new media artist. We've been in kind of exhibitions and panel talks and festivals of various sorts together over the years, but it was probably maybe 6 months ago that in following her on Instagram, I suddenly saw that she was doing this thing that not only involved bats, which I knew that she'd been working with, but suddenly machine learning recognition of bat communication kind of turns up on her Instagram feed. And I was just terribly excited by that. And I kind of resolved then and there to ensure that we'd be able to get Alinta along to a Leonardo talk sometime in the future. And so I'm very excited that we've managed it. And Dave Newell is a fantastic colleague of mine. He's also a mean bass player. Dave and I play music in the same band, but we also both teach at Southern Cross University. Dave is a fantastic scientist. And I reckon I first came across Dave's work, and especially Dave's engagement work, when we were all a group of us doing presentations in the science tent at Splendour in the Grass, thanks to one of our attendees here, Kristen Denexter. Hi, Kristen, your work continues. So Splendour in the Grass, some of you may know, an enormous music festival that happens, in winter in the Northern Rivers region here in northern New South Wales. And we were lucky enough to have a kind of a science tent to do engagement, entertainment, presentations of research to engage the many thousands of young people that come along to primarily listen to music, perhaps drink and take pills, but also to be entertained and made to think. And so my kind of enduring and endearing memory of Dave is sitting there at his presentation on his research with frogs. Dave is in a frog onesie and he's surrounded by this horde of kind of crazy Technicolor kids, eyes wide on pills or what he was talking about, just enraptured as he kind of narrated the story. And he just embodied what I think of as an engaged researcher in that moment. So again, I'm very happy to be able to present Dave's work to you. So we're going to start with Alinta, and Alinta is a multidisciplinary new media artist. She's co-founder of the Ephemelab Interaction Design Studio. She works also as a researcher of interactive art at QUT in Brisbane. She's interested in viewpoints beyond the human, looking to other species as end users, co-designers, and muses for her work. And she uses sensor-based equipment and machine learning and AI to find new ways of engaging with other speakers. She has an extensive exhibition list, which I'm not going to read out because it'll take too long, and there's some very long words in there. But I would say that one most recent and current exhibition would be showing your work, I think perhaps showing in Curiosity in Brisbane on South Bank right very now.
Yes, very soon, coming up next month.
Excellent. Okay. Well, with that introduction, I will leave it to you. Alinta, please take us away. Thank you.
Thank you so much. Thank you, everybody. I'm just going to quickly share my screen with you and get my PowerPoint set up. I apologize that I'm not coming to you from some sort of bat and/or frog onesie. That's a shame. We should have coordinated that to be getting into the onesies tonight. But so anyway, despite any onesies or not, I just wanted to say good evening to everyone in Australia and good morning and day and night to everybody beyond. I'd like to acknowledge the traditional elders, past, present and emerging of the land that I'm coming to you from today, which is in the Yugambeh speaking nation. So yes, I'm an interactive computer artist and researcher, and I've also been a volunteer wildlife carer on and off throughout my adult life. And so the work I'm going to be discussing with you today was essentially made in collaboration with grey-headed flying foxes in rehabilitation care, including those from an aviary run by Bats QLD. And I know there are a few members of Bats QLD here today. So if anyone has the capacity to donate to a great wildlife volunteer agency, head on over to their website. I'll pop it in the chat later on. So just briefly, the grey-headed flying fox is an Australian native, and it's a keystone species due to their work as nocturnal pollinators. They're also a threatened species being pushed to the brink by human encroachment, but also climate change. So they tend to mingle and communicate with other flying fox species in the wild and in care. But today I'll just be focusing on this species when I talk about the surrounding literature to The Bat Translator, very creatively titled, which is an interactive artwork and a piece of technology that integrates machine learning to interpret flying fox vocalizations in real time. This technology is actually made to run off a web browser, so you can access it yourself on your own mobile device, but there are some things to note when setting it up. So I'll point you to a how-to video in the chat afterwards. So for the Bat Translator project, I've been using machine learning technologies to listen to flying fox vocalizations and interpret them into corresponding human perceptible concepts, which kind of involves a mixture of literature review into current scientific knowledge on vocalization meanings and their contextual behaviors, as well as my own behavioral studies that were a part of my PhD, and also I think some healthy speculation. So I'm venturing into a kind of speculative digital writing to explore their communications to the best of some of the scientific knowledge that's out there of this species, but also to the best of my ability to interpret that as an artist and as a writer. So for context, the grey-headed flying fox is known to have up to 20 vocalizations within sort of 5 different vocalization types of distinct meaning. So this has been described by the vocalization researchers Christensen and Nelson, and so they're sort of the people who my work is following on from in a sense. but also during my time volunteering directly with flying foxes and living near 2 large roost sites, which is where I live. I often have bat visitors in the backyard. So I've been a part of, quite a few communications with them, and I've observed from a distance many communications that they've had with each other. So I'd like to start not actually by talking about the bat translator artwork, but by working through notions of anthropomorphism and communication as they pertain to species for whom we cannot know the subjective inner worlds, and the risks versus the usefulness of evoking the communications of another species via our own languages. So while I do this, you'll probably see I've been flicking through some images of the bat translator being used on a mobile device, so that when I do come to talk about it later, you'll recognize it. But I wanted to start by saying, so Ludwig Wittgenstein, a philosopher who was skeptical that other species could have what we know as language, once wrote that if a lion could speak, we would not be able to understand it. So animal trainer and philosopher Vicky Hearn responded that if a lion tamer could hear this, they would feel quite differently. She said, "What does Wittgenstein mean? That if my lion started talking to me, we would stop being able to understand each other?" Vinciane Desprez further added to the same conversation by noting that workers in industrial pig farms would be of the opinion that if animals could speak, we would get shouted at every day. And I think we would certainly understand why. What Hearn and Desprez wished to get across is that it may be ill-informed to believe that understanding of other species is thwarted by the inability to speak the same language. So I also take the same position in understanding that animals do, of course, engage in ways that we can learn to recognize through vocalizations, but also through their actions and their choices through which we all show our political cards. I think, for instance, about some of the viral videos I've seen recently of human-animal conflict, such as an orangutan attempting to fight off a bulldozer dropping down its home, a pig resisting the slaughterhouse, or a horse refusing to race. These aren't just actions without meaning, but statements that we shouldn't ignore simply for fear of anthropomorphizing them. So to look upon animal behavior without interpreting it, we're left only with an inability to recognize anything about other species at all. From this perspective, interpretation and translation of communications, albeit still to this day labeled anthropomorphic, helps us to predict, understand, and gain empathy for the actions and reactions of others. Psychologist Donald Hebb's comparison of anthropomorphic and non-anthropomorphic descriptions of the behavior of chimpanzees illustrates this really nicely. And I really love this quote, so I'm just going to read it out to you. He said, "A thoroughgoing attempt to avoid anthropomorphic descriptions in a study of temperament was made over a 2-year period, and all that resulted was an almost endless series of specific acts in which no order or meaning could be found. Not only did objective descriptions fail to capture aspects of behavior, but by the use of frankly anthropomorphic concepts, one could quickly and easily describe the peculiarities of individual animals. And with this information, a newcomer to the staff could handle the animals as he could not safely otherwise." So to some of this might seem pretty obvious, but Hebb's study supports the position that an approach to animal communication that renders our interpretation illegitimate results in an unnecessary inability to understand others. This is inappropriate to the reality in which life occurs and the ways in which we do interact with other species on a daily basis, and what emotional and cognitive expressions we might share. As scientist and historian Lorraine Datsun says, this dooms us to understand only our own kind. So Datsun and Hebb's words comfort me when working with flying foxes. I empathize with the ways in which their social nature makes them appear to yearn for company, yet they often jostle for position and get what we might call annoyed with each other as they're sharing space. I empathize with the sounds made by mothers when something threatening gets too close to their pups, the big wings display they give when they want someone or something to move back and they're perhaps feeling what we would call confidence, or the ways in which they share or squabble over sources of enrichment and sustenance. So the BAT translator aims to express this evocatively through machine listening technology that can recognize certain vocalizations and point them at particular written translations. So of the 20 grey-headed flying fox vocalizations mentioned earlier, 6 have so far been accurately listened to and translated by the BAT translator, plus a 7th sound, which is the sound of wings beating in flight, which is a sound that I also find to be meaningful. So for a bit of comparison, Aquilon's MeowTalk cat translator app from 2020, built by the developers of Amazon Alexa, started with 9 vocalizations for cats and has since been downloaded millions of times by humans desperate for their cat's voice to be translated without too much care for the scientific accuracy of those translations. So I think 7 translations is a really good start, and it can always be added to with time. So a little bit on the process for creating this. I began by obviously recording a wide range of vocalizations while volunteering and also having them sent to me by carers. I felt that integrating this into other volunteering activities gave a sort of an ethical resonance to the methodology, as it meant I didn't have to go near any wild roosts in order to record. And I could do this at the same time as sort of completing other rehabilitation-based activities for the bats. The process followed with careful classification of those vocalizations on each recording, resulting in what were originally 15 different classifications. So 15 different vocalizations, basically. So within each of these 15 classifications, the number of actual usable processed sound clips that I ended up with was about up to 40 clean clips each. So you can think of that as a bit like 40 different bats saying the same thing. I then attempted to decipher potential interpretations of these 15 vocalizations by connecting them to observed actions that I had witnessed, as well as through further discussions with other carers and the work of people like Christensen and Nelson. I also uploaded the classifications to a private online server and shared them with some other sort of batty people, such as organizations and researchers. And so through confirmation and sometimes debate, crowdsourcing really helped to back up or challenge or change my understandings of what I was doing. My process then continued by taking these classifications into a machine learning engine in order to translate it and export what's called a TensorFlow model. So for those who are interested in this, I used what's called an audio model, not what's called a wake word model, which means the machine was learning the pitch, the frequency, the timbre, and so on of these vocalizations, rather than considering them as human language, which is what the text-to-speech translator in your phone does. So this is technologically a simpler way of approaching machine learning. It also means it could be more likely to make mistakes. For instance, it may pick up a bird call that sounds like a flying fox call, but it also seemed to make the most sense given that flying fox vocalizations aren't necessarily equivalent to what we think of as singular words. They more likely indicate complete communications or complete messages or something like this. Along the way, I learned that to a machine's ears, bat vocalizations can sound quite similar to each other. So that's why I ended up eliminating some classifications and bringing it down to 7. So these were the ones that my microphone wasn't getting confused with. They worked really well in testing, and the model got them correct every time. Part of this process also involved creating a really large number of exclusion sounds for the machine to learn was not a bat call, such as I said, bird calls. I had to use a lot of those, and actually a lot of clips of me pretending to be a bat. So just, making random squawking noises and so on to try and teach it that a similar sound, but made by a different voice, wasn't something that it should be recognizing. So what I've just said is very much sort of oversimplified the process, but the process is long and tedious, and I'm happy to talk about it more afterwards. But I'll move on to thinking about what this real-time translator looks like to a human user. So I decided it required a screen-based design. I couldn't translate each vocalization into sound because you have to be standing near bats, obviously, to use it, and this extra noise might disturb them. So it caused me to think about how to interpret this silently and in a mostly dark visual output that minimized light emission as well, so hence the black background. I actually used to be a fiction writer, so interpretation of others' actions isn't so foreign to me. And I'm very excited that these things are moving on my screen because I didn't even think they were going to do that. That's great. So I wanted to create a sort of disjointed and purposefully confusing poetic grammar, plus some sort of simple animated colors and symbols to attempt to evoke sort of what a broken Flying Fox translation might read as. The written translation and visuality to me kind of represent the idea that a direct bat to text translator wouldn't necessarily come out in perfect English, as Wittgenstein warned. Indeed, it wouldn't necessarily be able to rely on words alone at all. It might have to rely on multimedia translation, ideally including smell, imagery, movement. It could be sound, it could be taste, or in my case, I was thinking of it as animation and color and shape. So interpreting that sort of initial Wittgensteinian way of thinking that, you know, it can't ever be a direct translation. I gave myself this kind of artistic freedom to imagine, well, if humans could understand bat vocalizations as written English, could it sound poetic and beautifully strange to us and a little bit confusing? So I'd like to obviously talk through a couple of the examples here just quickly. I've got some example screenshots here from the translator up on your screen. I've chosen some of the least confusing and more straightforward ones to show you today. So the translation you're seeing to the left of your screen actually refers to the sound of the flying fox wing flaps, as mentioned earlier. So this is a sound you're not actually likely to hear it if you live under a flying fox flight path, unless they come down quite close to you. But when you do hear it, it's quite an incredible sound, very distinct for a microphone to be able to pick up and very beautiful. The translation on the right is a bit more nuanced, and it refers to a sort of a small chirp that I would call a mild annoyance. So imagine you're sleeping on a branch, minding your own business, and someone bustles past you and knocks you around a little bit as they're coming by. And you just want to let them know that, hey, you're there, and they kind of got on your nerves a little bit for doing that. And that's the vocalization that this translation is connected to. So your presence forces my eyes open. It's not yet time for flight. I'm mildly annoyed at you. So remember that these are in sort of portrait because they're meant for a mobile device. The work itself doesn't really work on a computer because, you know, that's a bit cumbersome to kind of take outside. You have to be listening to actual flying fox voices to get it to work properly. So again, here are a couple that I considered to be a bit more straightforward ones, and one that's maybe slightly more nuanced. So the translation on the left is connected to a mating vocalization. So female bats during mating can make some vocalizations that I find hard not to anthropomorphize in a way that might be incorrect. So I've really tried not to do that here and instead imagine a more holistic picture of what bats might understand as reproduction, just kind of imagining what that might be. And actually 2 of the 7 translations in the bat translator are different mating vocalizations because they're decidedly quite different from other vocalizations, and therefore they're strong for my audio model to be able to learn and pick up. The translation on the right connects to kind of like a common chatter sound that you might hear between flying foxes who might be squabbling over food or territory. And in this translation, I've really tried to get at this idea that while they might be vying over something, they're also this very social species, and this vying occurs very commonly. You hear it all the time. And so I'm playing through this idea of imagining them saying that, you know, they want each other to go away, but maybe not too far away, or don't go away forever, or just go away to the other side of the roost. So to end, I think there's always a risk in either the misinterpretation of something an individual of another species is communicating, and there is a risk in not interpreting the full and complete scope and depth of what they're communicating. But similarly, we can do the same thing with humans as well, right? We don't actually know the inner thoughts of each other. And so while we can ask each other questions about how we feel, there's still a kind of interpretation that goes on between us. So if we think about the studies such as that one of Hebb's that I mentioned before about objectively removing interpretation from interactions, we can see that it's perhaps just as risky, if not more risky, to try, because along with interpretation can come empathy and the understanding that other species are not as empty and robotic as Western culture has positioned them. So this empathy from the perspective of translatable emotions and translatable communications is, I think, surely desperately needed today. So I have no idea how long I've spoken for, so I'll leave it at that. Thank you so much for listening.
Fantastic. Thank you so much, Alinta. You spoke for the perfect time.
How about that?
I know, it's amazing. And I can see there's been some lovely chatter going on in the chat. So please feel free to have comments, questions, what have you in the chat. And if there's certainly questions there, we'll loop back to them. We'll do questions at the end of the two talks. So, we'll just let them build up there. But when we come to discussion, we're also happy if people raise their little virtual hand, which you can find that down in the reaction section at the bottom of your screen. You can raise your hand and we can get you to you vocally as well when the time comes. So thanks so much, Alinta. We're going to move on now to Dave Newell. Dave is a senior lecturer in the Faculty of Science and Engineering at Southern Cross University. His research focuses on the conservation and ecology of Australian rainforest frogs. Current projects include climate change impacts on montane rainforest frogs, the ecology and physiology of the genus Filoria, and the use of ecoacoustics for monitoring threatened fauna and understanding host responses to the amphibian chytrid fungus. Looks like Dave has got his screen shared. Everything's happy. Thanks so much, Dave. Please take it away.
Thanks, Grayson. Hopefully everyone can see that. Yeah, it looks like it's working. Thanks again. I'd like to start by acknowledging that I'm on Widjabul Waible lands of the Bundjalung Nation and pay my respects to elders past, present and emerging. Always was, always will be Aboriginal land. So I titled my talk tonight, If a Frog Calls in the Forest and there's nobody there to hear it, does it make a sound? It's obviously a play on that if a tree falls in the forest quote, which has been attributed to an 18th century philosopher, George Berkeley. But it resonates with what Alinta's been saying. So is sound only sound if somebody's there to hear it, to perceive it? Very much an anthropomorphism. But we must remember that animals clearly use sound for communication. So in the case of the frogs, when there's other frogs there to hear it, yes, clearly they do make sounds and they do hear it. So I'm not much into the philosophy, but from a science perspective, I'm more interested in things like, when do frogs call? So what are the factors that drive calling activity in frogs? When should we be out there looking for them? And where in the landscape should we try to find them? So I've worked with a bunch of very rare species. So these are the types of questions that I'm sort of interested in answering and using ecoacoustics to do it. So how many are there? What's their trajectory? So are they in decline? Are they recovering? And what's going to happen in light of climate change? Of course, the artist in me, and after seeing Alinta's talk, I'm really interested in what they're saying now. So why frogs? Globally, around the world, amphibian species are in trouble. Close to a third of all amphibians globally are thought to be threatened. They are the most extinction-prone group of vertebrates of modern time. Within the Australian context, close to a quarter of our species are of conservation concern. And perhaps what's most concerning about declines and disappearances of amphibians is that they happen within the bounds of well-protected conservation areas, often upland habitats. We now know that disease and climate change are the key threats to amphibians, And these are really wicked problems in terms of conservation biology. So the group of frogs that I'm going to talk about tonight are the mountain frogs, the genus Phaloria, of which up until a month ago there were 6 species. They're Gondwana relics. So there's one species in Victoria which is critically endangered. It's called the ball frog, which is the bottom left of your screen. It occurs on, I think, a single mountaintop, Mount Ball. In northern New South Wales, we have this cluster of these frogs from about the Barrington Tops through to Main Range in southeast Queensland. And as I mentioned, they're all Gondwana relics. So these things come from a time when the Australian continent was covered in cool temperate rainforest. They're relictual species that have speciated based on the breakup of those rainforest blocks. The area in northern New South Wales that I'm based, sorry, my screen is doing funny things. Let's get rid of that, that's better. So I'm in Lismore, northern New South Wales, not far from Byron Bay, so if people are not familiar with the area. In this region, we have now have 4 species of these mountain frogs. They occur from Main Range in the northwest in southeast Queensland, through to the Richmond Range west of here and into Nightcap border ranges. We had suspected that there was a 4th species within this group, this funny little patch in between the Western Border Ranges and Main Range. And I can now announce that this species is known as the Mount Bellow mountain frog. So in February this year, we described a new species, worked with Newcastle University and the South Australian Museum, bunch of collaborators on that project. So amazing that we are still finding and describing brand new species within these rainforests, and it's testament to the incredible biodiversity of these World Heritage areas. So as the landscape dried over millennia, these frogs have basically been left isolated on mountaintops. They don't move far, so they can't disperse between intervening forest blocks. They live at the very tops of mountains in these sort of magical areas of rainforest, often dominated by Nothofagus. So again, another Gondwana relic. They live in the very headwaters of these streams. So where our rivers first begin. They're very cryptic in that you only know that they're there when the males call. They live underground. They construct a burrow or possibly use abandoned burrows from crayfish, we're not really sure, where the male will call and a female will deposit sort of up to around about 25 eggs in the burrow. If they're not calling, we can't detect them. Very rarely see them above the surface. So the species that I'm going to talk about tonight is the red and yellow bellied mountain frog, Phaloria kundagungan. It's been was previously classified as data deficient in that it was known from only 6 locations. And I think there was 8 records in total when we began this work. The work has been conducted by my PhD student. Sorry, my computer's really slowing down. So the guy on the right of the screen here, Liam Belitho. So most of the science that I'm talking about tonight comes from Liam's PhD work. He's done an absolutely outstanding job in furthering our knowledge of these rare frogs. We used unattended audio devices called song meters to document the calling phonology of these frogs. So we had those 6 locations and we deployed song meters at these sites and we programmed them such that they would record 10 minutes of audio every hour, and we did that over a 2-year period. We ended up with this amazing data set of around about 9,000 hours worth of sound recordings. that's a lot of sound recordings to go through manually. So we used a machine learning process to actually just play you some calls. So we can visualize what the calls look like. So here's some birds calling. It's that Lewin's honey eater. Get ready for it. Here comes the frog. There you go. That's it. That's a Bayesian thrush, or maybe even a lyrebird. It's tricky, that call. There's another frog call coming. It is. So using this software, we can visualize what the calls look like, but you can actually see that these frogs, although they're calling in a very noisy part of the day, there's another one, they're actually calling within this specific set of frequencies. So they have their own ecological niche in the soundscape. Okay. Getting a bit tired, that frog. So we had these 9,000 hours worth of recordings, and we needed to come up with a means of being able to sift through that data. So we developed a call recognition algorithm in some software called Kaleidoscope Pro. And it's not sort of this magic black box. It took weeks of work to actually get this algorithm to work. But at the end of the day, we ended up with, you know, a recognizer that was able to accurately detect the call of the frog. And we had a true positive rate in terms of call detection, which was greater than 95%. So we ended up with this amazing data set of knowing when the frogs call. Along with those sound grabs, we also captured data on the temperature and whether it was raining. We built up this amazing picture where we had more than 2 million calls that were detected from those 9,000 hours of recording. So remember that this is a frog that was known from only 6 localities and 8 records when we started. 85% of the calling activity occurred between September and November. And you can see that there's clear peaks in the calling activity. But what's really interesting, so most frogs are nocturnal, but these frogs are actually calling in a crepuscular fashion. So they call at dawn and dusk. And as I showed you in those sound recordings, they are also the noisiest times of the day in the rainforest. That's when all the birds are calling. So the take-home message from this data set is, you know, we now know when we should be going out to look for the frogs, and you don't go and look for them at night. When we looked at temperature and rainfall, we could also see that there was a clear pattern that you know, calling activity happened around about 14.5 degrees, and rainfall at the time of the recording was actually not a great predictor. And that may be because it interfered with our ability to detect the calls with the recognizer, but also if there was rainfall in the previous 7 days, that was a much better predictor. So they live in these burrows that are constantly moist. So probably when they're full of water, they don't really want to be calling so much, but rainfall in the previous 7 days. So we now know when to look for these frogs. But what about where in the landscape we should be looking for them? Again, my computer's gone slow.
Hey, Dave, if you turn your video off, your computer might speed up.
It's a good idea.
Sorry.
Which I can't quite get to. It's not letting me get to it.
But it's working for us, so don't worry.
Okay, so back to the red and yellow bellied mountain frog and where we should look for it. So what we did in this instance was we used that information that we had about localities, and we developed a GIS model to look for areas that had similar characteristics. So they were rainforest habitat within the predicted, to develop a model of the predicted range of the species. We then we identified 32 sites for targeted surveys, and we went out and established 100-metre transects and surveyed each of the transects 3 times within a season. The reason that we did it 3 times was that there's a chance when you go out and survey for a frog that it's not going to be calling. You want to build up a picture of the likelihoods that you're actually going to detect an animal when it's there. At the time of survey, we also recorded the temperature, rainfall, humidity, and obviously the number of frogs that we detected on a given transect. Using the GIS, we could also extract site level variables such as the elevation of the site, aspect, vegetation, average rainfall, and average temperature. We detected frogs on 52 of the occasions, so 100 odd surveys that we did, and at 21 of the 32 sites that we did surveys at. All of the populations that we found were very small, and we didn't detect them at 2 of the known historic sites. The area of habitat that we predicted them to occur in is highly fragmented. So again, these mountaintop streams, and they're restricted to an area of about 11 square kilometres when you just consider the creek line habitat, so an area of 20 metres of stream. Fortunately, most of the predicted areas are within conservation reserves, but that might not necessarily be enough to save these species. The likelihood that we would detect a frog was influenced by the temperature and the time of the survey. So that was as per our call phenology data. And the probability that a site was occupied was really strongly associated with elevation. So confirming that these are a montane species. So we did detect them below 800 metres, I think down to 680 metres, but as you increase in elevation, the likelihood that a site would be occupied was greater. So armed with that information about their current climatic niche and where they occur in the landscape, we can also use bioclimatic modelling to look at what's going to happen under various climate change scenarios. These things are living totally in islands in the sky. But as temperatures rise, Grayson, take note of the cloud stripping that's occurring. So these montane areas are constantly have cloud hitting the mountaintops, and that's a really good source of the moisture that drives these systems. Incredibly important. But as climate shifts, these sorts of things might stop happening. So we wanted to know, using the maximum entropy model, what is their preferred climate currently with all these new sites that we'd found for this frog. So we use bioclimatic models where we build up a picture with climatic data to look at, and the presence data, and we put it into a model called a maxent model, maximum entropy. We then remove those climatic layers that aren't contributing much, and we come up with a model of likelihood of occurrence. We can then apply a probability threshold. So you might get a model that is like from 5% to 100%. We say we're just interested in those areas that have a greater than 90% probability of the frog occurring. And then we then come up with this really good model of the climatic envelope of this frog. And this is what it looks like. So the climatic envelope, or the ecological niche for this animal, is about 300 square kilometres. The inset area on this map is of the areas in northern New South Wales. But when we look at what happens with 1.5 degrees of warming, so what's the future going to hold for these frogs if these habitats heat by 1.5 degrees? And we can predict that the climatic niche reduces by 64%. So 1.5 degrees is what we're on track for. This is happening, this is real. So we're going to lose about 64% of the habitat of this little endangered frog. If we go to 3 degrees, we lose 91% of its habitat. Now, when we first did these models, I thought they were a bit extreme. And it's like, is that real? Like, that's pretty savage. But then in 2019, 2020, we had the hottest and driest year on record. And we saw 1.8 million hectares of forest burn in Eastern Australia. We also saw these ancient Gondwana rainforests burning. These areas aren't meant to burn. This is climate change. It's happening. It's real. 30% of the habitat in main range for this frog was burnt. And we ended up with sites that looked like this, that were previously occupied by the frogs. Fortunately, we had this great data set prior to the fires that we were actually able to go out and do post-fire surveys with some funding through the Commonwealth Government. And we did find that frogs actually survived at some of these sites amazingly. However, we were far more likely to detect frogs at unburnt sites. One of the things that also happened post-fire is that the canopy opens up, you get further drying of the habitats. So it's a vicious cycle. But we also have seen in lots of areas, we've had pigs moving into habitat. And this is the sort of damage that pigs do to rainforest stream habitat. Just quickly, we also ran the models for the Richmond Range mountain frog. So again, this species is very restricted, has a climatic envelope of 226 kilometres. Under 1.5 degrees of warming, we lose more than half of its habitat. And under 3 degrees of warming, we lose 85% of its habitat. So look, even under moderate climate change scenarios, these frogs are definitely on a path to extinction. And we need to urgently investigate captive husbandry for these animals with a view to undertaking translocations to the wild and being able to bolster those wild populations. And that's where we're going with our new project, which we've called Project GRASP, which is the Gondwana Rainforest Amphibian Survival Project. And we have established at Southern Cross University, we've modified a couple of shipping containers, and we are breeding, or going to attempt to breed, the mountain frogs in these areas. We've also done some work initially just to see that we can hold adults in captivity, and we collected some egg masses, and we have been growing our eggs into tiny little frogs. I'm not sure if this video is working, but these things are tiny when they first hatch out of eggs. And these frogs, little froglets, are about 5 millimeters. And they're happily growing away. And that work's been funded by the Commonwealth Government through funds from the Saving Our Species program, the New South Wales Department of Environment. And we've also received funding from WWF, Rewilding Australia, in order to be able to do these experimental translocations into the future. I'll leave it there. Thank you.
Fantastic. Thank you. Thank you so much, Dave. That was just lovely. And simultaneously kind of horrific as every story that emerges from climate change and its effects on the property, on life everywhere, on every level. So we now get to turn to questions and comments. I can see there's been a few questions have already come up in the chat there. Great. And maybe I'll pass over to Elizabeth to begin facilitating some Q&A. And those of you who would like to ask a question using your microphone, please find your little hand down the bottom.
And then we can unmute you. So thank you, Grayson, and thank you to our two speakers for amazing talks tonight. So much to think about. And rather than taking on the co-chair's role and kicking off with a first question of my own, which I have many things to ask. But we're already getting, guys, questions from the chat coming through. So in fact, rather than start with my own question, I'm going to move directly into the chat and give our fantastic audience who have been making comments of enthusiasm all throughout both of your talks. I'm going to turn over now and take the first question from the chat. So I'm just going to reiterate for people who prefer to write their chat in the comments there. I'm going to keep collecting those, but as Grayson said, you can also raise your hand and we will unmute you in due course. But let me turn to the chat now and start by reading out one of those questions. And so this is the first question that's come in, and it's for you, Alinta. And that is, it's a question from Jason Walter Nelson. Great question. Thank you, Jason. And Jason's asking, what is the role of technology or the device between the flying fox and the human? And as a follow-up question, he's really interested to know the future of the project and whether there's a 2.0 or 3.0 on the horizon.
Yeah, look, thank you for that question. In terms of the device sort of between the human and the flying fox, yeah, it's kind of it kind of becomes a sort of a third actor, doesn't it? Because it in itself has the ability to make choices about what it's hearing. And I found throughout the process that, yeah, I really had to kind of give over some of that sense of trust to this sort of machine learning model to accurately or in any kind of way be able to listen to flying fox vocalizations and then make a suggestion or make a choice about that. And so it's kind of like, it's not just a direct communication between you and someone else, so that someone else being a flying fox. There's this kind of third person in the room as well, and it's the machine, and it can have its own biases and so on as well. And it's funny because the process of recording vocalizations and categorizing them and figuring out whether you've got it right, and then thinking, what's this going to be like as an artwork? What's it going to look like? How do I do all this? It's this kind of long and arduous process. And then after all that, I realized I could write one little tiny line of code, which basically said, it was basically a line of code that said, what percentage do you want this to actually work? Do you want it to be 100% accurate, or do you want it to be any percentage between 0 and 100? And I realized, hang on, after all of that, just with one little line of code, I could change this entire thing, right? So I had this line of code where if I'd set it to 100%, that meant that it almost didn't work at all, because it couldn't hear any other flying fox other than the exact ones that I had inputted. Or if I set it as sort of like 75%, then you're kind of saying, well, maybe you can pick up some other sounds as well. And so I think I ended up setting it at about 90%. So it has a little bit of an ability to kind of get things wrong, but therefore also pick up on all these other potential flying fox voices as well. But yeah, it was just kind of funny that after this entire process, I could just kind of change it and make the decision at the end of the day. And I can still go back in and change that whenever I want to. But in terms of a future for the project, yeah, the great thing about the code that I've created for this is that it's actually not too difficult comparatively to take that flying fox audio model and swap it out for something else. So that means other species, of course, you'd have to go through the process of collecting those samples and finding a model to learn them and so on. But once you had that, you can actually just swap it in and out and it will still work with the same code. So definitely that's something that I'm thinking about is where to go from here now. What other species could I interact with? What's useful in that way, and just basically building on that. Yeah.
Fantastic. Guys, other questions are appearing in the chat here. And so I'm making a list of them as they come in, and everyone is thanking you for your great response there, Alinta. But actually, before we move on to the next question, and then Grayson, maybe for the next question, I'll turn to you and you can take one of the ones from the chat there. But I think that question about, so what is next for the project that we just had for you, Alinta, is a nice one to turn to you as well, Dave, before we move on, because you were giving us some sobering data in there as well. So I wonder, that makes us kind of pause for a moment and think about that. So I wonder if I can turn to you the same question that Alinta just answered, and you can tell us a little bit about what the next steps for your work and project might be.
Yeah, thanks for that, Elizabeth. I guess for us, we're at a point where we are wanting to be sure that if extinction happens for these animals, which it looks like they're on a path to extinction, unless the current government can turn things around for us, and we actually get some real action on climate change, let's hope, fingers crossed. But we, I don't want to be going back to these sites in 15, 20 years time. Am I actually going to be able to do that? I won't be able to climb those mountains then. But I want to know that we can have an insurance population. Being able to do the captive husbandry work can take many years. I noticed that Michael Vella's online here. Michael's doing amazing work up at Currumbin Wildlife Sanctuary with some endangered frogs up there. But these projects can take a very long time to be able to actually work out how to do the husbandry. So we want to get an early start, and looks like it's going well, and then look at how can we use translocations to try and solve some of these wicked problems. So I'm also looking at doing animal translocations for another species which is highly impacted by the disease. But if we can look at ways of perhaps introducing some degree of tolerance, so if, for example, with these little frogs, that if we could get them a bit more heat tolerant and then release them, that might be a way to help solve the problem. With the disease issue, we're looking at animals that have come through a period of severe decline and have actually naturally recovered and able to cope with the disease. And we're going to reintroduce them to a site that they went locally extinct at Wollumben. So working with the traditional custodians of those sites to reintroduce them there. So that's the next big project too.
Great. Thanks so much. Okay, so we have another question. This one is for Alinta, and this is from Kristen Denexter. And Kristen is asking, have you combined the playback of the bat chatter recordings with the poetry? So I guess, have you, developed those things in tandem somewhere in another form, perhaps?
Yeah, so I haven't done anything like that yet. This is what I did in order to test the work. So I've gone out and tested it in the field, but I've also just used recordings and played them in my room with the bat translator to make sure it works. So that was the actual testing process. But yeah, I really like that idea in terms of as an art exhibition or something for humans to engage with, to have this sort of auditory experience in a room, because of course the thing that I've created here is so strongly based on audio, and yet it's silent. And often when I first explain it to people, they'll say, oh, so it plays sound. No, it doesn't play sound, it listens to sound. And so there's no actual sounds involved in it. But yeah, in a sort of an in-gallery situation that had an auditory experience as well as a sort of visual experience. So yeah, that would be really, really nice. Perhaps that's version 2.0.
Cool. And yeah, I'm going to do what Elizabeth did and kind of ask Dave the same question. I mean, obviously, I'm a media artist. I love art science work and the kind of endless and unceasing possibilities that occur, and especially within the idea of translating science into other contexts. So I can't help thinking, if you've got 9,000 hours that then became X number of perfectly machine identified frog calls, I mean, you have an incredible creative data set as well. Is that part of your thought now or in the future? Are you collaborating with anyone? How would you think about these things as material for creative work as well as work for scientific analysis?
Yeah, well, it's not just a data set, you know, it could be used for all these other purposes, and it also creates a moment in time, so that data can be revisited in 20 years' time by other researchers or artists to look at, or what was happening in these forests when those recordings were made. So yeah, it's just large amounts of data, so a lot of storage. But what I was thinking, Grayson, was I know that you love working with clouds, and that little bit of footage I showed you of this process of cloud stripping, and it's so incredibly important for montane ecosystems. And I'm wondering, like, maybe we could look at that imagery that you've captured and try and create a record of when these mountain peaks are covered in cloud and when they're not, because as you've identified, those Landsat imagery, when there's cloud, it's kind of rubbish data to them, but it's actually not, because in this context, it's like, well, when are there clouds and when are they not? Is that baseline shifting?
Yeah. So as in, if we can see the mountains on the satellite, there's a problem. If we see them regularly, yeah, there's a problem.
We stop seeing clouds.
Yep. Yeah, let's do something, Dave. Very good.
Grayson, should we move on to the next question then? So we're just nicely taking it in turns here. So as a manner of turning to the next question, which is from Anna. So I'm going to share that, but just following on from what you guys were just talking about, Dave, when you were showing like the data of the sound that you have as well, like some of the visualizations of that. So this is following on from Grayson's question about that. It really reminded me of, I saw the Bernie Krause piece at the Sydney Biennale recently. For anyone who hasn't seen that, it's an amazing sort of data visualization piece and a sound visualization piece. It was at this year's Biennale. And Dave, I was really thinking of your, thinking of that piece while I was seeing some of your images and listening to your work. So for people who haven't seen it, there are these amazing sound files of animal field recordings, but taken over a period of time. And I was wondering if you saw some resonance with this yourself, Dave, that some of his earlier, Bernie Krause's earlier pieces, for those, they're very noisy in terms of that there's a lot of animals that he's getting his field recordings of as sound. And then when he plays sound recordings of the last few years, suddenly they're much quieter. Have you had a chance to notice that kind of change over time, that there's less sound to capture or less visuals to capture?
Not in our recordings, but yes, I mean, that's what I'm referring to, is like, if in 20 years time somebody could do a comparison, and I love that stuff that's happening from Bernie Krause. There's also a group at QUT who have been creating these amazing visualizations of a year of the soundscape and creating colorizations. It looks amazing. It's a totally different way of dealing with soundscapes. The type of work that we're doing is that we're very specific about trying to pick out little bits of audio, so we're using it to actually target individual animals, and it's incredibly difficult. I think we got lucky with this frog because it has such a simple call, but when you get into really complex calls and you're trying to do this stuff, I think it kind of falls over. But there's a project that's happening with the Australian Museum, which is called Frog ID. and they're encouraging people to record 30 seconds of audio of frogs that they hear calling in their yard, and they geotag the location, submit the audio file. Using the technology that we're using, we could potentially get that happening straight away, where you're actually able to recognize what the species are that you're hearing. But at the moment, they've got a group of people that sit there and listen to the audio recordings and then write back to you and tell you what you've got, but add to this amazing citizen science database, which I love. It's great stuff. So the Frog ID is the app.
Frog ID app. Very cool. Thanks for sharing that, Dave. Alinta, I'm going to turn to you now with a similar question. This comes from the chat from Anna, who asks, are you planning to create a similar translator for microbats as well, and also human flying fox translator for things that we might like to say back to bats as well? So do you have any thoughts about expansion along those lines of the translator?
Back the other way. Yeah. First, I'll say, just to go back to the previous conversation that David was just having, it just made me think about how it's so hard for us as humans when we think about climate change to recognize time scales and to recognize that while, this kind of downfall of species, or the changes from being very noisy to being very silent, has happened, over, say, 20 years or whatever it is, in the grander scheme of things, that's such a small amount of time. And I think it's really difficult for us as humans to kind of recognize that, and to kind of recognize in terms of deep time how quickly that's all happening. And so I think that, that's perhaps really where art can step in as a type of science communication, to kind of think about trying to make it clear to people in, through data visualization and so on, just how expansive, time really is, and just how quickly things are being quashed in the current sort of situation. But yes, sorry, to answer Anna's question, microbats are a very different kettle of fish, because you can't hear those vocalizations with the human ear. So when we're starting to talk about echolocation, this is something that's kind of beyond our range of hearing. But of course, things like David was mentioning the sound meters. There are sound meters that are specifically for bats and specifically for picking up echolocation, and they can take that and kind of bring it down to the level where humans can hear it. But in terms of machine learning that can listen to that, I'm sure it can be done, but I don't know how to do it. So that's kind of a bit out of my kind of area of skills, but that would be really, really interesting in terms of thinking about, of course, how do we visualize echolocation, and how do we perhaps imagine ourselves a little bit into the eyes of the microbat. I think there's a very famous paper from the 70s, and I'm trying to remember now the name of the person who wrote it. I think his last name might be Nagel, but it was called something like, learning how to be a bat, or something like that. And it was basically an entire explanation about how we can't ever see out of the eyes of another species directly, which of course plays a lot into the kind of work that I've been doing recently. And he used a microbat as an example, because his example was about how echolocation as a way of seeing is so different to the way we see the world, that how could we possibly ever imagine it? And perhaps with sort of virtual reality, we could start to think about something like that might be similar. But so microbats would be awesome, a little bit out of my area of expertise. But in terms of going back that other way, human back to flying fox translator, I would be worried about getting it wrong and saying something a bit offensive. I'm not I'm not sure if sort of the technology is available yet to do it in a way that would be correct. And I guess the only thing, what would you say? What would you say if you were talking to a flying fox? Really, the only thing that you might say is something like, I mean you no harm, or don't go over there, that's a bad place, or calm down while you're doing a rescue or something. Those might be the sorts of things you want to say. So it might be about at first trying to figure out what is the vocalization that pinpoints that meaning, and then seeing if you can just create that and just kind of play it. Could be what you end up doing. Yeah, that's a really great idea. I'm going to steal that idea. Thank you, Anna.
There's sort of some animal ethics issues that we need to think about too when we start talking to, or wanting to be able to talk to animals. I think that's one of the great things about this technology, is that it removes us somewhat from being in their habitats, so we can remotely monitor, for me, the frogs. So, I don't actually have to be traipsing through frog habitat to do the monitoring in some instances.
Yeah, exactly. And I think the same for me, coming from that perspective of, this could be something that's useful for bat carers. They're the kinds of people who are likely to be near bats. The kind of general population isn't likely to be near them. And indeed, they say don't go near them on purpose. And so, yeah, that kind of sense of thinking of who's the right person to have the technology in their hands. Yeah.
We have another question. This one's for Dave, and this is from Jasper. And Jasper's asking, in regards to this work towards making the frogs a little more robust in terms of higher temperatures, he's asking, have there been thoughts or plans around making them more robust in terms of drier habitats, and perhaps setting up burrows for the frogs that can self-cool?
Really interesting. So there's work happening in Western Australia with some of the endangered species that they have there, where again their habitats have been drying. So I'm not kind of totally up on it, but yes, potentially making some sort of refuges within the landscape for those species might work. I'm really not sure I'm just putting it out there as a possibility that we might be able to make them more heat tolerant, but certainly with the disease stuff, I think we can do it.
Yep. Great. Do we have do Alinta or Dave any further questions for each other, or Elizabeth? Have you must have a store of things sitting there, and we've got a little bit of time, and I think we've run through all the questions in the chat at this point.
I think we do. So yeah, I was just about to say to everyone as well, we're probably getting to the point where it's last call for the questions. We've been working our presenters hard as well. I guess one of the things that really, leapt out about the conversation for me, and we're getting a lot of comments like this in the chat as well. So Grayson, it might be nice to capture the chat before we wrap up today for our speakers, but to have us a nice record of the proceedings, because there's a lot of comments in here as well, appreciating the dialogue between the arts and the sciences going on in here. And it's not just, a conversation between the two of you, Dave and Alinta, but also within your talks as well. One of the things that I really appreciated about the way that both of you talked about your work and your use of different, the videos as well as the sound files to make recordings of the material you're looking at, is the extent to which you kind of problematize the role of translation in your work. And, Alinta, you were the one who spoke about this first, so it really, leapt out at me in your conversation that you talked about, you started off talking about machine learning programs, for translating with, very very scientific, to talk about the translation work that you're doing with bats. And then you mentioned, oh, of course, and my background is as a fiction writer as well. And then that gives you a whole sense of a different dimension that you're bringing in terms of the complexity of the concept of translation that you're bringing with your work. Sometimes we see these animal translation services and it's like, oh, your cat says meow and it means this, as though it's a direct translation. But of course, you spoke about it in a much more nuanced and complex way, what you're actually doing, you know, as the process of translation. Is that for you something that directly comes out of your background as being a fiction writer, that you bring a more complicated understanding of what it might be to go from one language to another? Or are there other ways in which that background is informing the work that you're doing here?
Yeah, I think that for me, it just comes from a position of, you know, having that history in writing and a history in coding and a history in sort of the collaboration between science and art. You get from every direction people making comments based on their methodologies and their way of seeing things. And so I almost get kind of defensive in a way, and I feel like my talk might have been defensive. I hope it didn't come across that way, in terms of, you know, trying to speak on that scientific side of things, but also speak on the art side of things, and to kind of be inclusive of all the different theoretical areas that are kind of in the background of what you're doing, you know, because if you just say, oh, I'm a writer, so I'm just going to say what some animals said, then, you know, of course, everyone on the animal behavioral science side goes, well, wait a minute, no, like none of that doesn't mean anything. You're just making that up. But then if you go just from that side, the people on the art side will say, well, how is it interesting and evocative, and what does it do for people? And so I'm just trying to come at it from both sides, if that makes sense. And I think that, you know, when you're in this kind of art science field, you get used to developing a kind of a methodology that is a combination of these sorts of different areas that your work looks at. And you know, I spoke about, of course my work is a type of translation, and so inevitably the word anthropomorphism rears its ugly head, and you have to talk about it in some way or another and make a decision as to whether it's worth doing, and whether there's a positive side to doing that. And you've got to explain that, you know, I might be completely wrong. We might all be completely wrong about this, but this is kind of an evocation into that. So yeah, I think for those of us who are sort of artists that have a sort of a flavor of science communication in what we do, we're kind of combining these methodologies. And as we spoke about just briefly before, I think that at the end of the day, you can combine as many things as you like. And the most important part is to ask the question of, am I doing it ethically? Am I doing it from a position of care? Am I doing it for something that ends up helping those animals? You know, I don't want to put my aesthetic and my art first. It's about, you know, make a piece of art that ends up doing something positive for that species at the end of the day. So, yeah.
Yeah, I love that about your work, that the really nuanced kind of configuration of the phenomena, kind of knowledge domains and phenomena that you bring together. I just find it enormously sensitive. Yeah, and that so thank you so much for being able to talk about this project here. I really appreciate it.
Oh, thank you. Yeah, it's just a lot of reading and time.
I think that's what strikes me most when I first came across it. It was like, oh my God, this must have been so much time and so much, deep intricacy and complexity. But then to end up with an app that kind of spouts bat poetry is such a great way to translate that labor and that complexity into something really accessible.
Yeah, and I wouldn't see the point of doing it. I mean, no offense at all to cat translators. I think that's brilliant. But yeah, I wouldn't see the point of doing it if it was just entirely fictional. The fact that it's got some realness and the actual kind of behavioral science behind it kind of makes it more interesting to me.
Mm.
I think we're drawing to a close. Our exhortations for last calls have gotten lots more expressions of love and many thanks from people who are leaving.
And what a great dialogue between bats and frogs we had tonight. That was just so, speaking of translation, such a wonderful range of perspectives in your work and such an interesting dialogue between the two, the work that both of you are doing. I'm going to leave inspired with a lot to think about.
Yeah, it's been really exciting. I think, Alinta, we're going to have to come up with some glasses that you can actually visualize being a bat, some echolocation. You walk into a room and somehow visualize what objects are through echolocation.
Yeah, absolutely. And it's so nice that, that everyone here tonight is thinking about these important species and species that are under threat. Both of us have spoken about these species that do such important things and really deserve to be here and deserve to have time spent on them, that we really need to look after these particular species in the future.
Absolutely.
Well, guys, there's a lot of love for both of your projects in the chat. So I hope you get a chance to catch up on all the thanks and the congratulations for your wonderful presentations and responses to questions and comments tonight. So generous, both of you, to give so much time and thought into this event.
Thank you so much.
Thanks for hosting, and thanks for all the questions.
And thank you to all of our attendees. We really appreciate it. We love seeing you here. Thank you so much. I hope you've enjoyed the evening. We will no doubt be in touch and let you know what we do next.
Yes, definitely.
Thanks, Dave and Alinta.
Thank
Bye,
you.
everyone. Thank you.
All right, thanks everyone.
Bye, guys. Thank you,
Thank
Grayson.
Hey, Mandy.